Hi, this is Shayan Shaha. I manage the Red Hat storage product line in Red Hat. Today I will be talking about the Red Hat storage server product line, and I'll give you a brief overview of its key features and functionalities. The agenda for this session looks like the following. So I'll start by explaining some background on what is Red Hat storage, what are we trying to solve with it today, and take you through some key features and technology highlights, how it is productized, what basically, if you had to buy this from Red Hat, what will you get, what are we focusing on the current shipping release. We also are announcing the RevRes integration beta with this product today, where Red Hat Storage will become a storage provider for Rev, and then conclusion and Q&A. So basically, my goal here after this session is that you walk away with a very good understanding of where this product plays, what are its key features, and what you can do with it. There will be other presenters that will talk about specific integration parts and features and all that other stuff. But the plan here is for this meeting or for this session is to basically warm you up to what it is, what it can do, so that you have a good overview of what it is for and what it can do before you walk into the other sessions. So with that brief introduction and agenda, I will get to our next slide, which talks about unstructured data growth and acceleration. Now, in the storage industry, for the last few years, I'll say 5 to 6 years, we have been observing a very interesting trend. The trend is about growth of almost exponential growth of unstructured data that has been caused by multiple reasons. It's being created by users every day with their devices, handheld devices, mobile phones, tablets, etc. It's being caused by increased virtualization, where a lot of servers, bare metal servers in data centers are getting consolidated into virtual machines which have images, and there's a huge number of those in any enterprise. It's being caused by a lot of these factors, which has created an interesting situation in the market, where the unstructured data is growing at a very fast rate compared to the structured data. Now, when I say unstructured data, I basically talk about files and media and objects, things that you cannot store in a database, like an Oracle database, where you have records that are extremely structured. So everything needs to have rows and columns, and they go into there. Now, while the structured data market has been growing too, it has not seen the level of growth that the unstructured data has seen, attributed to various factors that I just mentioned. So as a consequence, we'll go to the next slide, where as a consequence, what we see is there are some very interesting factors at play, where we see the traditional storage market is ripe for disruption because volume x86 economics can play in this market in exactly the same way it has played in the x86 server market in the last decade, where we basically saw Linux and x86 obliterate all kinds of proprietary traditional server systems, and pretty much it's all x86 right now with your favorite operating system, whether it's Windows or Linux. We see that same trend applicable to the storage market, which traditionally has been very appliance-based. So you buy the hardware and software together in one box, and you get what you get in terms of interfaces that are offered by the storage appliance to you, and you're limited by what you can do as the vendors, provide a very limited access to the box itself, and it's basically a black box to you that gets shipped to you and you bring it up. Now, so because of these factors, one, unstructured data, explosion of unstructured data growth, and volume economics offered by x86, we have seen a trend where the biggest storage deployments in the world, which are in companies like Facebook, Google, Yahoo, etc., are solving the storage problem not using traditional storage gear but software and community hardware, which has provided a good enough solution that enables people to deploy storage at petabyte scale, and is able to drive market dynamics in a way where traditional storage solutions don't fit well. So this is where Red Hat storage comes in. We define it inside of Red Hat as an open, unified, and extensible scale-out network attached storage software solution for on-premise, virtual, and cloud environments. So that's in a nutshell the definition of what is Red Hat storage today. And as we go along, I'll introduce to more features and capabilities of this solution, but primarily it's a scale-out software solution that has the capability to aggregate disparate set of hardware containing disks into one single unified namespace that can be mounted as a single mount point. So this is what we show in these slides, where via access protocols like NFS CIFS, a native client, and Swift, which is an object interface, you can access Red Hat storage via a single mount point. And if you need more storage, you can just add a few more servers with disks in them, and the mount point just recognizes that it has more storage now. So fundamentally, this is a scale-out storage solution. So you get all the benefits of basically seamlessly either increasing the data storage pool or decreasing it without the application even realizing that. And this can be basically built on any kind of commodity off-the-shelf hardware, which is great because we don't need any kind of secret sauce hardware or hardware acceleration or proprietary hardware logic to provide the services. So the whole idea is quality superior software running on commodity hardwares to provide storage serving for unstructured data environments. So with that quick introduction, I'd like to introduce you to the key features of Red Hat storage. So Red Hat storage was designed to be highly scalable. When we say highly scalable, we really mean petabyte scale and more. It is truly, if you look at the architecture of Red Hat storage, it has been built with unlimited scale out in mind. So it is really truly unlimited scale out. There is no limit to it. For support perspective, we do have a limit, but in the end, it has been designed to take in petabytes and petabytes of data and grow seamlessly. The other, really cool feature of Red Hat storage, it's highly flexible. You can deploy Red Hat storage in a bare metal environment, a virtual environment, in the cloud, that is pretty much anywhere you like, and you don't have to worry about moving storage boxes from one place to another, or how will I take my storage to this site from that site, etc., because it's software based and can run on any commodity hardware. So if you had a data center today with a bunch of servers, you can basically turn them into storage servers by deploying this solution. If you don't have a lot of servers lying around, but you have existing capacity in your virtualized environments, you can start serving storage from disks that are in that, in those servers if they are unused, using Red Hat storage. If you don't have a data center at all, you could just move all of this to the cloud and use Red Hat storage in Amazon Web Services and just do storage serving in the cloud. Whatever your goals are, we will be able to help you with a solution, and this is very key, because traditional storage, typically is big iron, a box that needs a data center to go into. You plug it in, it comes up and it works, but you really don't have much flexibility in terms of taking it to the cloud or using VMs to serve out disks, excess capacity of disks that may be captive in your current existing environment, which you are not using. So that's a very key feature. It's also highly cost effective compared to traditional storage gear. We are 3 times or less less expensive at the least, even when you do replication. And with us, as I said before, you can actually be able to serve out storage from unused disks that are in your virtual environment. So that's something you could do too. So that's key, and all of this is open and standards based. So there's nothing which is very specific to Red Hat storage. If you love your current access protocols, be it NFS or SIFS, Samba or HTTP for object storage, we support all of them, and we support all of them together. So you can basically use a dual interface like capability. So if you could use, for example, the HTTP based object access protocol to add files to storage, and then use NFS to retrieve those files. So that will basically allow you to use this kind of storage in all kinds of environment, and you don't need to keep specific storage for specific access protocols and then copying back and forth from one to another just because you wanted to run virus scan. So that's something that's important to note. Let's go to the next chart here, where we talk about some of the key technology highlights of the solution. So as I've already stressed, the solution here that we sell is software only and open source. So Red Hat is a software company, infrastructure software company, and this is not against that. It's software only and open source, which makes it very flexible. You can take it and deploy in lots of places, as we talked about. The technology is fundamentally user space. It's not a kernel space technology, which actually gives us lots of degrees of freedom, so that we can deliver functionality at a rapid pace without waiting for kernel merge deadlines, and makes it easy to install. The Red Hat storage is extremely simple to use. It overlays on top of existing Linux file systems, and it's really easy to manage using command line as well as graphical user interface. It provides unified file and object access, which basically allows you to access the storage using both these kinds of interfaces. So if you have a customer who wants to upload a picture from their iPhone or their smartphone or tablet, they can do so. to Red Hat storage, and later if you want to access that picture using your traditional file tools, POSIX based, you can do so using the file. So that eliminates a lot of hopping back and forth between two different kinds of storage, because it is not siloed towards just one kind of data. So it supports both kinds of interfaces. Red Hat storage is modular and stackable. What this basically means is when you create Red Hat storage volumes, you can specify exactly what kind of features you want at that volume creation time, so that you can, what you want gets created right away. For example, if you wanted to do encryption and compression, you could create a volume with both. Or if you wanted to just do encryption and no compression, then you could do so. Again, if you wanted to do distribution but no replication, you could do that. If you wanted to do both distribution and replication, you could do so. So all of these choices are available to you at volume creation time, which makes it very flexible. So it's not something that the customer has to enable or has to be shipped in one shape or form, where you can only do this but not that, and if you want that, you need additional things to do. The data in Red Hat storage is stored in native formats. They actually go into standard Linux file systems like XFS. As a consequence, Red Hat, you are not locked into any kind of proprietary data format or on-disk format. If you decided to walk away from Red Hat storage for some reason, the data is all there, completely readable using conventional means. Red Hat storage also does not have a metadata server, which is very common with most scale-out file system storage technologies. A metadata server is a component where you store information regarding a file's location, and that's something that is consulted before you go and look up the file. So when you have to look up a file, you actually first go and hit the metadata server, query the metadata server, asking for where is the file, and once the metadata server gives you that answer, you take that answer and go to the server in question. Red Hat storage server does not need such a metadata server. It uses a hashing algorithm by which the client simply knows in which server a file is stored. So that's a very, very cool and efficient way of doing things, because as soon as you have a metadata server, you have to worry about making it highly available. You have to worry about distributing the metadata so that it doesn't become a bottleneck, and all other kinds of things that usually goes with such component technologies where you store file locations. So that's very unique for Red Hat storage. So with that overview of the technology highlights, I'd like to show a chart that actually pictorially represents exactly what makes up the Red Hat storage technology stack. So in light blue or gray, at the bottom of this slide, what you see is already in Red Hat Enterprise Linux. So it's basically the RHEL storage stack that we build upon. The dark blue, or the blue overlay on top of the RHEL storage stack, is the Red Hat storage functionality or capabilities. So as you can see here, we are using here a completely enterprise class and proven and mature storage stack that comes from Red Hat Enterprise Linux, and we are exploiting the capabilities that are in that stack to build upon the additional functionality that Red Hat storage provides as an unstructured data storage solution that can scale out seamlessly. So some of the key concepts in Red Hat storage pertain to these three things, which are a volume, which is basically a namespace presented as a POSIX mount point, which is comprised of bricks. The brick is the basic unit of storage, which is represented by an export directory on a server. And then servers are nodes which actually contain all these bricks. So these are the three key concepts, and once you familiarize yourselves with these three, it's a very easy technology to understand, and you'll see this in our documentation and guides where we talk about this extensively. In the end, the volume is the ever-encompassing thing that basically aggregates the bricks, and the bricks are in every server, and each brick is nothing but a file system. So with that fundamental concepts in mind, we'll go to the next slide where we talk about the two most important or the popular volumes that we have today. The first one being distributed volumes. Now, distributed volumes by nature don't have any replication built in. So the whole idea here is you can add as many servers you want with disks in them, with local disk storage, and you can use Red Hat storage to aggregate all those servers and basically export one single mount point. So it's a big concatenated volume. In this kind of a volume, you have only one copy of a file. So if for some reason a brick is down, like the brick on server 2 in this picture is down, you won't be able to access file 3, but as soon as the brick is back up, you should be able to access it. So there is no redundancy in this kind of volume. But the throughput for this kind of volume is obviously high because there is no overhead of copying files in different bricks. In the next chart, we show you the other important kind of volume that we have in Red Hat storage. It's called the replicated volumes. The replicated volumes is basically a volume where you have more than one copy of a file. So as you can see in this picture, the bricks in server 1 and server 2 both have file 1 and file 2, which basically gives you a lot of high availability and redundancy with respect to file availability, because if server 2 was down for some reason, the brick will go down with it, obviously. But that doesn't mean your application won't be able to see file 1 and file 2. They will still see it. And if they make changes to file 1 and file 2 while the brick on server 2 is down, Red Hat storage will make sure that once the server 2 comes up, the changes that have been done on file 1 and file 2 while the server 2 was down are replicated over to the files on server 2, basically files on server 2, so that the copies are consistent and there's no inconsistency between them. So Red Hat storage has a built-in logic to basically detect differences between the different replicas of a file and heal them, HEAL, heal them as needed to make sure that they are consistent. So with that, I go to the next slide where I focus on the productization aspects of Red Hat storage. So what can be stored in Red Hat storage? So as I talked earlier, Red Hat storage is a really great fit for all your unstructured data needs. It's not good for structured data, but it is indeed very good for all kinds of files and folders that stores documents, photos, videos, and images. If you have big data, log files, which are more like semi-structured data, RFID data, and any kind of long-tail data, which can range from music videos that haven't been accessed in 10 years to pictures, or things that you want to keep around just in case there is a need to access those at some point of time. So Red Hat storage is a great fit in most of these cases. So if you're considering to build an unstructured data repository, for your enterprise, then come see us. Chances are we'll probably have a good solution for you. So In this chart, we talk about how Red Hat storage is productized today, and really, it's very simple. It is a software appliance which is pre-integrated and pre-verified. So we deliver it as a DVD ISO image, and it contains Red Hat Enterprise Linux, the XFS file system, and GlusterFS, which is the file system that the scale-out file system that is at the heart of Red Hat storage. So it's a combination of these three things, and we also supply a management console with it, which is in tech preview currently, technology preview status currently. So the whole idea is you take this DVD ISO, you install that on a server of your choice that you buy from your favorite vendor, and this software basically takes your regular commodity compute server and turns that into a storage server. So that's the whole point. So what you get from Red Hat is a DVD ISO, and then you can have this obviously registered to Red Hat network and update the ISO from time to time as we release patches and bug fixes and enhancements. So it works just like any other Red Hat product today. It's not different. We give you ISO, you register it with RHA, you get the updates, and it keeps running. So with that, I go to the next slide where I basically describe if you were to buy a server today for Red Hat storage server, what are the vendors which we have declared support or compatibility with. So these 8 vendors are basically pre-approved for using Red Hat storage server with. However, we have a requirement that the servers that you select must be in the Red Hat Enterprise Linux 6 certified hardware list, or the HCL as they call it, the hardware certification list. The knowledge base article at the bottom of the slide gives a detailed description of what server hardware we recommend for what kind of use cases, and which hardware vendors are included and why, what JBODs, what's the maximum number of disks per server, how many JBODs can be attached, etc. So if you're interested, just look at that KBase, and it has a great deal of detail on what can be done here. So in the next chart, we talk about the 2 variants, the next 2 charts, the 2 variants of the product. So Red Hat Storage Server comes today in 2 different variants. The first one is called Red Hat Storage Server for on-premise. This is basically the solution for bare metal data center. So you could take Red Hat Storage Server DVD ISO and put it in your bare metal data center, or you can put it inside VMware or Rev to serve out storage that you might have in form of unused storage space in existing servers. So this is the solution to get, or this is the variant to buy if you plan to use it on bare metal or virtual environments. However, there is another variant which is we call the Red Hat Storage Server for Public Cloud, that comes in form of Amazon machine images, and the whole idea is you can take this and run it in AWS. And currently, Red Hat Storage Server for Public Cloud is available in all Amazon regions and zones. So you should be able to use it anywhere in any part of the world. So with that, I briefly touch upon what has been the Red Hat Storage Server 2.0 areas of focus. So our current shipping version of Red Hat Storage Server is 2.0. It was released in June of 2012 at Red Hat Summit, and its key features that we focused on was making it enterprise class, because we acquired a startup called Gluster, where we made the technology acquisition, and we put a lot of effort in making it robust so that we can stand behind it. we also made a lot of improvements in providing services for unstructured data like disaster recovery and remote replication. And we also improved file-centric storage use cases. So, looked at performance for NFS and the native client and make sure that they were at par with what enterprises expect. So we basically focused on making sure that we are a good NAS alternative, scale-out NAS alternative into the market. Now, what we are announcing during this virtual event is a very interesting use case. We are announcing this as basically a service pack, or I would say a service pack, but we are announcing this as basically a beta. We are announcing a beta where a customer should be able to basically store Red Hat storage, Red Hat Enterprise virtualization Rev images in Red Hat storage. So that's something we are announcing today, and we are announcing the beta for it now, hoping that it will go to general availability in a few weeks from now. The initial integration between Red Hat Enterprise Virtualization and Red Hat Storage has been achieved using the native client that goes into KVM and using the native client of Red Hat Storage to mount the Red Hat Storage pool. Rev introduced a new storage domain with Red Hat Storage Rev 3.1 called POSIXFS, and we are using that in order to be leveraged by Rev as a storage pool which will basically store VM images or Rev VM images. So we are very excited about this beta. We are announcing it today, and we are eager to get input from you. This beta also contains in tech preview status a version of the RevM console which is primarily used to manage the Rev data center, but in addition to that, it will also manage some of the storage functionality, or provide some of the storage functionality, and manage some aspects of the Red Hat storage cluster. So with that, I come to my last key takeaway slide, which is what is Red Hat Storage 2.0 in a nutshell. It's storage software, server software installed on community server and storage hardware. It's pre-integrated and pre-verified, and it's ready to run. It's extremely flexible and easy to use. It creates a powerful turnkey, massively scalable and highly available NAS and object store in minutes. And you can use it anywhere, in a data center, in public cloud, or hybrid environments. And in addition to that, we just opened up a new use case for it today as we announced the first phase integration of Red Hat Enterprise Virtualization with Red Hat Storage. And we will be keen to hear from you on how it goes. I'm hoping that a lot of you will take a beta version of it and start testing it. So with that, I end my presentation today. Thanks for your time, and looking forward to talk to some of you in future. Thank you.